In this video, we're going to be talking about single replacement reactions. So there's an element plus a compound gives a compound plus another element. An element, remember, is something that is not combined with something else. So examples would be things like our diatomic elements, like hydrogen, for example, or just sodium. They should have no charge on them whatsoever, so they should have no positives or negatives on them. Remember that a compound can be more than two things combined together. And again, compound has zero net charge also, so there should be no positives or negatives on it also. In order to help with the understanding of single replacement reactions, I just want to go over this part of the periodic table. That when you look at the periodic table, there is kind of a staircase. There is these metals over here and these non-metals over here. So when I talk about a metal and a non-metal, those are how we distinguish them. If we find them on the left side of the staircase, they are a metal. If I can find them on the right side of the staircase, they are a non-metal. The other thing is if they're negatively charged, they're considered a non-metal, so many of the polyatomic ions are non-metals, and if they're metal, they're positive. So trying this one, for instance, aluminum reacts with hydrochloric acid. Aluminum would just be Al, again with no subscripts, so no little numbers, no charge at all, so it should just be Al. Hydrochloric acid is a very common acid, right? And if it's hydro and ic acid, that means that it had to have a hydrogen and chloride, and hydrogen is positive and chloride is negative. So this is kind of the beginning of it. From just writing out what I have here, from the wording of the question, I can see that this is an element and this is the compound. Now, in order to get kind of a better understanding of who is kind of going to dance with who, I'm going to write all the metals in blue, and I'm going to write the non-metals in red. Okay, so in a single replacement reaction, what you actually have happening is kind of a switching of dance partners. So this right here, this compound, they're kind of like one dance partners, and then this person wants to cut in to the dancing. So how do you tell who dances with who? Well, here's where this color coding comes in important, and also this discussion of that we had before about metals and non-metals. Aluminum is going to cut in and want to go with chlorine. So aluminum is going to want to go with chlorine. Now the reason I know that is because aluminum, and I'm just drawing out the charge of aluminum, this would be like on my scrap paper so I can help figure out the formula of it afterwards. Aluminum is the metal, right? And chlorine is the non-metal, and so those two can go together, whereas aluminum cannot go with hydrogen. That just doesn't work. The two metals don't go together. They actually almost like repel each other like magnets. So back to this compound. When aluminum goes with chlorine, we will get AlCl3, like so. Now somebody is left without a dance partner, and that somebody is hydrogen here. So hydrogen is left without a dance partner. Now I cannot simply just write hydrogen like this. I have to write hydrogen as H2 because it is a diatomic molecule. So now it is just a matter of the bookkeeping, right? Figuring out, hey, do I have the same amount of each one? So underneath, if you're new to this, you could make a little list. You could say on this side I have 1 aluminum. On this side I have 1 aluminum. On the reactant side, remember again that these are called reactants. On the reactant side I have 1 hydrogen. On the product side I have 2 hydrogen. On the reactant side I have 1 chlorine. On the product side I have 3 chlorines. Now we need our bookkeeping lists to be the same, right? So we need the bookkeeping lists to be the same. So you want to kind of start with weirder things that don't happen so often. So probably starting with hydrogen or oxygen is not the best route to go. Probably the best route to go is to start with chlorine. It's also a great idea to start with a pencil because then you can erase it if you make a mistake, right? So starting with chlorine, I see that I have 3 chlorines here. Well, this is a good one to do because if I put a 3 in front of here, so yes, indeed, that does change this to 3 chlorines, but now this changes this to 3 hydrogens, right? Oops. Well, now here's the thing. There is no number that I can put, whole number I can put in front of here that is going to make that be 3 hydrogens. So instead, I'm going to use my handy dandy eraser, which we were just talking about, which is great. And I am actually going to erase that. I am instead going to write a 2 in front of here to make this chlorine an even number, which is 6. So I'm going to put a 6 here now. So that changes this to 6. That also changes it to 6 over here. Now that reason I did that is because now I have an even number of hydrogens, which I can put a 3 in front of to get the 6. Now I also have 2 aluminum, so I can put a 2 in front of here. So this is the final one for this one. This one is actually a tricky one to start with. Okay, let's try the next one. So iron reacts with zinc sulfate, and it would be like write out the reaction for this. So again, using my color coding, I would say that iron is a metal, and it would be Fe, right? And it's going to be blue because it's a metal. And on my scrap paper, so I can figure out the formula, I have zinc, which is 2 positive. And I have sulfate. Sulfate, notice, ends in ATE, so that's a polyatomic with a weird ending, right? So I'm going to be looking at a special chart for that. I notice that zinc is 2 positive and sulfate is 2 negative, so that means that they cancel each other off. So I have zinc, sulfate, like so. Now it's a matter of figuring out who is going to dance with who, right? So iron and zinc cannot go together because they are 2 metals, so the 2 blue ones cannot go together. What we have to have is a metal and a non-metal going together, or a positive and a negative going together. So what I'm going to see is that iron is going to go with sulfate, and zinc should be all by itself. So easily I can just write zinc because that one is all by itself. It is not a diatomic, so it won't be in 2s. Now the trick here is I'm going to have to figure out iron and sulfate. So sulfate is SO4, 2 negative. But hey, what kind of iron do I have? Because when I look at the table of ions and I look at iron, I can see that iron can be iron 3 positive or iron can be iron 2 positive, right? So I have to figure out which kind of iron it is. There's no way for me to tell from here or from up here what kind of iron it is. So when you can't tell, you automatically assume that the iron is the first one listed, which is the 3 positive one, because that is the most commonly occurring one in nature. Now as far as the formula goes for this, then I will get Fe with the 2, because the 2 is going to come down here. And I will get SO4 in brackets with the 3, because the 3 is going to come over there. Now, you might want to list out some ways to balance it. You might want to look at SO4 as a total group rather than separating it into sulfur and oxygen, so we'll try it that way. I'm going to start with iron, so there's 1 iron over here, there's also 1 zinc over here, and there's 1 total sulfate group over here. There is 2 irons over here, there's 1 zinc over here, and there is, 1 zinc and 3 sulfate groups over here. So starting with iron, I want to balance it out so that I have 2. So I'm going to put a 2 in front of the iron. The zinc, I'm going to leave alone for a second. The sulfate, I see I need 3, so over here I'm going to put a 3 in front of here. Again, remember that you can only change the coefficients in front. You can't put subscripts on or superscripts on, right? You can only put coefficients in front. So that changed this, but it also changed the amount of zinc. So I have 3 zincs now. So now I'm going to have to put a 3 in front of here to get the zinc to balance. And now it looks like I'm balanced. Okay, let's try another one. So you might want to pause it here and see if you can do it first all by yourself, or you can just follow along as you go. So I chose this one because I wanted to see if you could figure out if it was chlorine and it's reacting with aluminum iodide. So if chlorine reacts with aluminum iodide, what we're going to see is now we have 2 red and 1 blue instead of like the usual 2 blue and 1 red. So in terms of switching dance partners, the chlorine cannot go with iodine because that's 2 nonmetals, so that isn't going to happen. So instead, aluminum, which is a 3 positive ion, is going to go with chlorine, which is negative. Now, what formula or what would the compound look like? So this 3 is going to go down here, right? So we should have Al and then Cl3. And then who doesn't have a dance partner now? That would be the iodine. And iodine is a diatomic atom. So just like chlorine was written like this, we have to write iodine like this. Okay, this is a great one to do too because this one is about getting kind of the lowest common number between the 2 things. For instance, you'll see here that there is 2 chlorines and over here we have 3 chlorines. And again, you can write out your list if it's new to you or if you're just learning, right? It's a great idea to kind of make a list of what you have and figure it out. Over here I have 1 aluminum, 3 chlorines, and 2 iodines. So notice that, again, chlorine I have 3, and here I have 2. So the number that they can come to common in is, the first one is 6, right? So if I multiply this one by 2, and I multiply this one by 3, then I get 6 chlorines. That also changed the aluminum over here to 2. And so in order to get the 2 aluminum over here, I'd have to put a 2 in front of here. But that changed the iodine to 6. So now I have a 6 there. That means to get 6 iodines here, I'm going to have to put a 3 in front of here. And now it's balanced. Okay, let's try another one. Okay, so again, you're more than welcome to pause it if you want to, and then see if you can come up with the reaction first. If not, you can just follow along. So firstly, calcium. So calcium is Ca positive, and it's going to react with aluminum sulfate. So aluminum is a metal, and you might have to like do your scrap paper, right, and look up, hey, aluminum is positive. Sulfate is that weird polyatomic that looks like that, right? So it looks like that. So that means that the 3 is going to go over here. This 2 is going to go over here. So we're going to get Al2 and then SO4 with brackets around it and a 3. Okay, so in terms of dancing here in my single replacement reaction, if I have to look at who is going to go with who, the calcium and the aluminum cannot go together, right? It has to be a metal and a non-metal. So now calcium is going to go with sulfate instead. So do not, it's really common to take the subscripts from over here and kind of somehow put them over here. Don't do that though. Make sure that you always go back to your table of ions and look up, hey, that calcium is 2 positive. Oh, what's that sulfate again? Oh yeah, that sulfate is 2 negative, and now they're going to go together. So that I get CaSO4. And the reason I don't have any extra subscripts is because this is 2 positive, this is 2 negative, they cancel each other off. And then who's left without a dance partner? Well, that would be aluminum, right? And that would just be Al, no subscripts, because it's not a diatomic or anything like that. You don't bring the subscript from over here back over either. Okay, and so let's try and get it to balance now. So let's look at it like this. So over here I have on my product side 1 calcium, 1 aluminum, and 1 sulfate. Over here I have 1 calcium, 2 aluminums, and 3 sulfates. So I might want to start by doing the sulfate group. So I have 3 sulfates, so I want to make 3 over here. So I'm going to put a 3 in front of here, and that makes the 3 sulfates. I have 2 aluminums here, so I'm going to put a 2 in front of here to make this 2. And now this also changed this, so I have 3 calciums over here. So in order for them to be 3 calciums over here, I'm going to have to put a 3 in front of here. So now it looks like I'm good and it's balanced. So we can go on to the next one. Okay, now this is like an extra tricky one. So again, you can pause it if you want to and then try it on your own, or you can just follow along. Here we have sodium, and it's reacting with water. Water is actually this. I would strongly recommend writing water like this when you're reacting it, so when it is on the reactant side. Because if you write it like this, you tend to get the wrong reaction. So you want to make sure that you're writing it like this so that you can see what is actually getting to react with the what. So sodium and hydrogen cannot go together. So that means that sodium and hydroxide are going to go together. Sodium, so like on my drawing board, is positive, right? On my table of ions, hydroxide is negative. Therefore, sodium hydroxide looks like this, because one is 1 positive and 1 negative. And I also have hydrogen left over without a dance partner. Remember that we have to write H2 because it is a diatomic molecule or a diatomic element. It doesn't like to happen by itself. Okay, now in order to balance it out, you can look at it as this. So I have 1 sodium, 2 hydrogens, and 1 oxygen. Here I have 1 sodium, 3 hydrogens, and 1 oxygen. Did you catch that I have 3? Because I have 1 here and 2 here. Okay, and so in order to get it to balance, the best thing is I'm going to kind of have to get these to be the same somehow. The way that I see this happening is by putting a 2 in front of here. That changes this to 2. That also now changes this to 4, which is an even number, which helps me out a lot. And this becomes a 2. Okay? Now, this one over here, I'm going to put a 2 in front of here to make the sodium balance. To get 4, I can easily just put a 2 in front of here. And now I have my 2 oxygens also. So then it works out. Again, make sure that you write water like this. the tendency is for people to write water like this, and then tell me that it is this, which is wrong. So you have to realize that water is like a hydrogen with a hydroxide. Okay, last one. So you can try it on your own, or you can follow along. But we have chlorine, which is a diatomic molecule with antimony iodide. So antimony 5 iodide. So antimony, scrap paper, antimony is Sb, sorry about that. Sb, and iodide is negative. So that means that would be Sb I5. Okay, a metal and another, a non-metal and another non-metal can't go together. So therefore chlorine and iodine aren't going together, right? That means that antimony is going to go with, antimony 5 is going to go with chlorine now. Just to take note that if it is antimony 5 here, then it has to be antimony 5 over here. It can't change to another charge there. It has to maintain the same antimony, so you can't change the charge of that. So this is 5, then it's 5 here. So that means that my formula would be SbCl5. And then who's left without a dance partner? Well, that would be, that would be iodine, which is a diatomic molecule. Okay, and now it's a matter of getting it to balance. So you might want to make the list underneath of Cl, Sb, and I, Cl, Sb, and I. So on the reactant side I have 2, I have 1 antimony, and I have 5 iodine. Over here I have 5 chlorine, I have 1 antimony, and 2 iodine. So this is going to be like, I have to come up with a number that they have in common, right? So the number that they have in common would be 10, and I get that by multiplying these two numbers together. So 5 times 2 is 10. So in order to get that, that means that here I have to put a 2 in front of here. That gives me the 10. It also changes this to 2. And to get the 10 over here, I'm going to multiply this one by 5. And I'm going to have to do the same thing with these two. So I'm going to multiply this one by 2 and this one by 5. And just go back and check, right? This is 10. And over here, this is 10. We're okay. This is 2. This is 2, right? The iodine, I have 10. And the iodine, I have 10. So now it is balanced out. The next video should be on double replacements that you should watch and make sure that you get a hold of that one with the 2 switching dance partners now.